Okay? Do the x values repeat? How do you determine if a table is a function? Do the x values repeat? Now, looking back on pages 1 through 4 of your notes, what is that similar to? AKA the first page of notes. What is that similar to? No. What's the first thing that we learned about? A what? Starts with the letter D. Discrete. It's the same as discrete graph. Not only is it like the same as a discrete graph, everything is the same as a discrete graph with a table. So in a discrete graph, how did we determine the domain and range? What did we use? Starts with an L, rhymes with ist. A list. Same exact thing for the tables. We're going to list our x values for domain, because that's what domain is our x values, and the range is our y values, and we're still going to list them. This is exactly like a discrete graph. That's how simple this is today. So we're going to look at the top left table first, okay? And remember, we're looking to see if do the x values repeat. So I look at this first table and I look only at the x values. Do any of these x values repeat? Yes. 7 and 7. These repeat, okay? However, do my y values repeat? Huh? No. Now, there's a reason why I'm asking this. Because if I have repeated values, if I have a repeated x value, double check your y value. If the y value is the same, it's like the person who made the table just made a mistake and rewrote the same ordered pair twice. However, these are two different y values, so this does not represent a function. And where does it not represent a function? At x equals 7. That's where it repeats. Okay? Where x equals 7, that's where it repeats. So that's why it is not a function. Because 7 repeats and it has two different y values. Remember, in order to be a function, at one singular x value is only allowed to have one and only one y value. This has two. Okay? Let's look at the bottom right. Oh, holy cow. I told you. Y'all didn't tell me I skipped two different lines. Goodness. Okay? Domain. How do I list my domain and range from a table? It's very simple, especially from the domain. Your x values in any table that you got or get or will receive will already be in order from least to greatest. So I just got to copy it down. So I got -2, -1, 7. Do I write the 7 twice? No. Gosh, I'm so glad y'all remember that. So then I just go to the 9 and I write the next one. Becomes a little like, now I got to do some work, all right? Because I got to figure out the lowest of the y values. What's the smallest y value I am given? What is it? -2. Once I do that, Coach Kimball scratches it out so he doesn't look at it again, so he doesn't make a mistake. What's the next lowest? Yeah, scratch it out. What's the next lowest? Yeah, what's the next lowest? And the last one? Victory. Now we can look at the bottom right. See, y'all gotta keep me on my toes, you know. So that's a vertical table. Here's a horizontal table where it goes from left to right. Anytime you have a horizontal table, your x's will always be on the top on a horizontal table. Okay? So looking at our horizontal table, I have 0, 6, 8, 6, 0. Do I have any repeated x values? How many? 2 sets, right? I have 2 sets repeated. I have 0 and 6 repeated twice. Okay? Here's where you got to ask yourself, do my y values repeat? At x equals 6, do I have two different y values? No. They're the exact same, correct? Would you all agree? This is where I'm telling you, you need to treat it like maybe the person creating the test made a mistake and wrote the same ordered pair twice on accident. Okay? So he wrote the same ordered pair twice. So this doesn't even count. However, if I was only given that this was my repeated value, I would say this is a function. But because I have two sets, I got to look at the second set. Okay? So, no, these don't not no. Yes, they are the same. Okay? Yes, that the y values are the same. Looking at my x equals 0, are my y values the same there? The answer to that question is no. -8 is not the same as 0. So I have two different y values for my x equals 0. And because of that, this is not a function, because at x equals 0, that's where it repeats. To have a function, by definition, each x value can have how many total y values? Use your words. I'm holding it up. 1. Each x value is only allowed to have one y value. At the x value 6, we had the y value -6. That's the same. So that means there's only one y value, -6. At x equals 0, I had 0 and -8. That's two different numbers. So that's why it's not a function. Questions, comments, concerns? Tables don't seem too complicated, do they? Nah. So let's talk about a map. How do we determine if a mapping is a function? I'm so glad you asked that question. How do I determine if mapping is a function or not? Well, you ask yourself, do the x values repeat? What's this the same as? Discrete graphs. It's the same as a discrete graph. Holy cow, so simple, so easy. Okay? How do we determine domain? Lists. Yep. And the range is listing the y values. Okay? Now, in order for a graph or a map to be a function, I'm going to put this little extra note. That's a star right there. That's a star. Each x value can only have one line connected to it. Okay, now that'll make more sense when we actually talk about the actual map itself. So each x value can only have one line connected to it. Now, in a map, all right, let me ask you this. In an ordered pair, what comes first? X or Y? X. Now, what order is that? Starts with an A, rhymes with alphabetical. Alphabetical order, right? It's in alphabetical order. Okay? Just like in a map. A map is also alphabetical order. So X will be the left, Y will be the right. Always. Always. Okay? Now, I said in order to figure out if we are dealing with the function or not is we're seeing if x values repeat. How do we see if they repeat on a map? Each x value can only have one line connected to it. So if I look at each one of these values, okay, 9, do you see how it only has one line here? So that's good. 8, one line. 6 only has one line. 4 only has one line. 3 has how many lines connected to it? 2. So this is not a function. This is not a function. Because x equals 3 has 2 lines. It's that simple. The y values. Can the y values have more than one line? Yes. Do we even care about the y values technically? No. What do we only care about when determining a function? The x values. All right? Now, to list your domain and range, it's very simple. Very, very simple. I'm just going to write every single x value in order that has a line connected to it. 3 has 2 lines, but I only write it how many times? Once. 4 has a line, 6 has a line, 8 has a line, and 9 has a line. Close up your fancy squiggly parentheses, and that's your list of domains. Your range is the y values. Now, the most important thing is the only y values I write are the ones that have a line connected to it. I have 1, 2, 3, 4, 5 total numbers in the y section. Do all 5 numbers have a line connected to it? No. So it's basically like that 7 isn't even there. It's like that 7's not even there. If there's no line to it, it's not a part of my problem. Now I just write the ones that I do have. I have a 3, I have a 4, I have a 6, and I have a 9. Bada bing, bada boom. Bada bop, bop. Questions, comments, concerns? Again, very simple, right? Does the x value repeat, yes or no? Okay? That's literally all you got to ask yourself. Does my x value repeat? If the answer is yes, then it's not a function. If the answer is no, then it is a function. Simple, easy, breezy, beautiful. Cover girl. No? Okay. No one uses CoverGirl products? Have you all seen those commercials? Okay. Well, moving on. In a map, X is always on the left-hand side. Thank you very much. Okay. Now I'm going to look at each X value and to see if I have any X value that has more than one line. Do I have any X value with more than one line? No. So that means we do or don't have a function. We do have a function. Okay. Because no X value has more than one line. So I can go over here to domain and list out all my X values. What's great about maps is they're already in numerical order, so I just got to copy it down. That makes life so much easier. My Y values. Do any of my Y values repeat? Yes, 6 has 3 different lines going to it. However, do we care? No, we don't care. We only care about is which ones do I have to write down? And it's the ones that have a line going to it. So I have 6, 7, and 8. Look how easy that is. That's all we do. Tables and maps, they're basically the same thing. Just a different way of writing it. Questions, comments, concerns, or hinklepinks? Any kerfuffles? Any smudgeons? No splendiferosalis? Sweet. Okay. Now to move on to the supercalifragilisticexpialidocious stuff. Anyone know what that's from? Yeah, Mary Poppins. Glad someone knows. Great movie. Real world situations. So in the last 6 pages, I've either given you a graph, or I've given you a table, or I've given you a map, or I've given you a set of ordered pairs. And I just asked you, is this a function or not? Well, you're going to have to be able to take a word problem, write an equation from the word problem, just like what we learned in Unit 1 when we transcribed equations, and then determine if it's a function or not. Easy. And then translate that to different representations, multiple representations. Just because, Ben, can you read this whole sentence, 2 sentences? Is it? Yeah, 1 sentence. I want you to read this section right here, and that's it. Just read that part, only that part. Okay, so tickets to see the new Spider-Man movie cost $11 per person. Anytime I see that per, I know that I have a variable being multiplied to my x. That's what that word per means. So it's $11 a ticket per person. Now, I, Coach Kimball, invited 4 people to join me. I'm going to go to the movie no matter what. Flat out. I'm going to the movie. Doesn't matter if anyone joins me or not. So what's the lowest number of people that can go to a movie? 1. Okay? Lowest number of people that goes to a movie is 1. All right? Now, if 1 person comes with me, how many total people showed up? 2. If 2 people showed up, how many are at the movie? If 3 people showed up, how many are at the movie? If all 4 people that I invited show up, how many people are at the movie now? Did I just create a list? Do I have any half of a persons? No, I don't have any half people, because I'm definitely not going to pay half price. That's for sure. Because of that, my info that I have is discrete. My equation. We're only talking about tickets. We're not talking about popcorn. We're not talking about drinks. We're just talking about the cost of a ticket. My equation is going to be what I have from the word example, real world situation. And I'm going to put it to y equals 11 times x. Where x is all my domains and my range is dependent on whatever my equation says. So if 1 person goes to the movie, how much money did we spend? If 1 person goes to the movie, I spent $55? 11. What on earth? If 1 person went to the movie, how much money was spent on a ticket? $11 was spent on a ticket. 55 and 44, holy cow. If that's how much it costs for 1 person to go to a movie, I'm not going to that movie. I'll wait till it comes out on HBO. Or Disney. Like Thor Love and Thunder. It's about to come out on Disney Plus. I think tomorrow. Okay? If 2 people go to the movie, how much does it cost? $22. If 3 people go, how much does it cost? If 4 people go, how much does it cost? Now, Tim, if every single person shows up to the movie, how much did we spend on tickets? $55. That's an ugly, fancy, squiggly parentheses. Does everyone understand why we have a list? can I have half of a person? No, a person is a person no matter what. Flat out, a person is a person. That's how you tell if it's a discrete or continuous. Can I have part of something? If I can have part of something, then it's continuous. If I can't, I can only have whole values, then it's discrete. Okay? Now, to take domain and range and make a graph, it's very simple. I have my x values, which is 1, 2, 3, 4, and 5. I have a graph here that goes up to 10. So I'm going to make my graph, I'm going to skip every 2, and I'm going to put 1, 2, 3, 4, and 5. There's my graph on the x values. I have 11, 22, 33, 44, 55, similar to that. So I make my graph here, every 2, 11, 22, 33, 44, and the tippy top, 55. A discrete graph has what on it? We wrote this on the first page of the notes. A discrete graph, not gaff, a discrete graph has what on it? Dots. Thank you, checkers. Dots. They both start with the letter D. So I'm going to plot these points. So when x was 1, what was my y value? 11. When x was 2, y was 22. And so on and so on. Do I connect the dots? No, because we have what type of info? Discrete. Discrete means don't connect. Dots. D as in discrete, D as in dots. Leave the dots there. Don't connect it. Once you connect it, it's now continuous. And we can't have half of a person. Mapping is very simple. All right. Don't complicate your lives. Take your lists and copy them down. Now, it's not technically a map until we draw what between them? Lines. So 1 went with 11, 2 was with 22, 3 was with 33, 4 was with 44, 5 was with 55. Now it's a map. A roadmap to success in math. Now, this was considered a map only when I put the lines. If I don't have the lines, it's basically a table. Did you know that the only difference between a table and a map is one has lines and one doesn't? For my people watching my video notes, I just did the mind explosion. The difference between a map and a table is a map has lines connecting. A table has nothing. They're just written next to each other. So to go from a table to a set of ordered pairs, I just get rid of the table. And I write it in parentheses. Mind-blowing things happening here. Mind-blowing things. Mind explosion. Turn the page. Who would like to read that section right there? Thank you for volunteering, Tim. Read this section right here on page 8. Okay, so I start with a pool that has 4,500 gallons of water. Now, if I drain said pool, am I gaining or losing water? Losing. How do we show losing? Subtracting. Now, what do I subtract by? 500 gallons. What does this word tell me? Multiply with the variable. Fantastic. Ka-chow. Good old Rusties. Now, we need to figure out if this is discrete or continuous. Now, I told you in discrete, you had to have, if you have nothing but whole values, it's discrete. Now, what about this situation? Can I have half of a gallon left of water in that pool? Could I have 2 3/4 gallons of water left in that pool? Do you see how I'm asking myself, can I create a fraction within my info? If the answer is yes, our information is continuous. Because I can have part of, based on the situation, part of something. Now, my equation is literally what I wrote up here, except the only difference is it's an equation, so it needs an equal sign. Y will equal 4,500, your starting value, minus the amount of water we're losing per hour. Inequality statements is the only thing that we will use during continuous. No, like when we're talking about a table, we're talking about a map, a set of ordered pairs, dots. Those are all lists. The only time we use inequality statements is with continuous. That's it. So I like to go into those blanks and just start right there. Okay, now domain. That is my mystery value. What is our mystery value? What's the title? Hours. Okay, y'all know what I'm talking about. It's hours. Okay, X represent the number of hours. Now, when I first start, when I literally pull the plug in the pool, how many hours has passed since I put my hand in the water and pulled the plug? How many hours has passed? 0. It doesn't take me 1 hour to reach my hand in and pull a plug. 0 total hours have passed. 0 total of hours. Next thing, okay, looking at our range, when I have my pool, what's the highest level that pool will ever be? 4,500. That's the most that water will ever be in that pool. So now, how do I find the other stuff? Well, domain, okay, think about the situation. Can I have negative water? No. When I have no more water, what's the value of that? How many gallons do I have in the pool? 0 gallons of water in the pool. Oh, wait. That's my Y value over here. 0 gallons of water in the pool when I'm finished draining. That's the lowest amount of water that can be in the pool. How do I figure out the most amount of hours that it takes? It's very simple. You take your equation. You're going to put, where you see Y, you're going to put 0 equals 4,500 minus 500 times X. And you solve it. The lowest Y value I got is 0. So now I solve. Subtract 4,500 to both sides. Now I have negative 4,500 equals negative 500X. I'll divide by negative 500 to both sides, and I get 9. Takes 9 total hours for that pool to be completely drained. 9 hours. Okay. Easiest thing to do to go from this information is to go from domain and range to a map. Don't go to the graph first. Go to the map. So I have 0 and I have 9. Those are my 2 x values that I have. Okay? My 2 y values. I have 0 and I have 4,500. My map needs to be in numerical order. That's why it looks like this. Okay? Now, this says use any 4 points. I have 2 already. Can y'all give me 2 numbers between 0 and 9? 5 and 4. So we got 4 and 5 is what we decided. This is where you take your calculator. Okay? Now to figure out these values here, I'm going to go to, everyone click on y equals. Do this with me. Everyone click on y equals. Everyone do this with me because I want y'all to get used to it. Oh, got to get our calculators. So we click y equals. In the equation, we're going to put this equation here. 4,500 minus 500 times x. To get the x variable, you hit the alpha, that button right here, that button next to the alpha. Just click that. Don't touch alpha. Just click that button right there and it gives you your x. Okay? Then I want you to hit second, blue button, graph, and that gives me a what? It's this button right here. That button right there. Just click that. So now I'm at my table. I chose 4 and 5 for my x values. If I go to 4, what's the value of the water? Thank you. I'm literally pointing at it. Okay, 2,500. After 5 hours, what's the level of the pool? Okay. This thing is an amazing tool. Okay. I didn't have to do much math. Okay. I just went to y equals, plugged it into the calculator, hit second graph to get a table, and then there you go. Do you see how in the -1, see that right there? You see that? How it says 5,000? That's not possible because we're talking about a pool. So I only worry about 0 all the way through. Hey, look, 9, 0. What? So I didn't even have to do all the solving. I could have just plugged it into the calculator and it tells me. Oh, man. What a missed opportunity that was. Sarcasm. Okay. In order for this to be a map, what do I need? Lines. Read between the lines. So I connect them to all that they're connected to. When 0 hours have passed, I have 4,500 gallons of water. When 4 hours had passed, there's that much left. 5 hours had passed, that's what's left. When I have 9 hours, that's how much is left. Okay? The graph is very simple. All right? I try not to overexert myself when I'm labeling my graph. I'm going to make this very highest y value, 4,500, and the highest x value that I got is 9. Okay? I'm not going to overexert myself. I'm going to put a point at the highest and a point at the lowest, and then I'm just going to connect the points. That's what Coach Kimball does. I have a graph. Easy peasy lemon squeezy. Now to go from a map to a table, it's very simple. I'm at 0, 4, 5, 9. Those values will, X values will always be least to greatest. 0 hours passed. 4,500 gallons of water in there. 4, 2,500. 5, 2,000. 9 hours, 0 gallons. And the only difference between a table and a set of ordered pairs is just putting parentheses around these. It's the only difference there. 0, 4,500. 4, 2,500. 5, 2,000. 9, 0.